हेलो स्टूडेंट्स। पिछले वीडियो में हमने इलेक्ट्रिक फ्लक्स डिस्कस किया था। हमने सीखा था कि इलेक्ट्रिक फ्लक्स कैसे फाइंड करते हैं एक इलेक्ट्रिक फील्ड के लिए। तो बेसिकली हम इसे समराइज कर रहे हैं। आई एम समराइजिंग इट कि दो टाइप के सिचुएशन हमें मिलते हैं जिसमें हमें इलेक्ट्रिक फ्लक्स फाइंड करना होता है। बेसिकली वी हैव टू फाइंड इलेक्ट्रिक फ्लक्स फॉर टू टाइप्स ऑफ सिचुएशन। द फर्स्ट, electric field is uniform and area vector is also constant, means कि both is having a fixed value. And the other situation कि maybe कि electric field is non-uniform, it is not the constant, it is varying. So maybe there is a varying electric field and even the direction of area vector is not same over throughout the area. So maybe कि area is also varying or maybe कि both is varying. Then in this, these are the two basic cases. So all types of flux we can divide it two category. Either it will fall in this category or in this category. There is no any third category. So first category, first case कि if both is constant, both is uniform, then simply to find the flux we have to take the dot product of two. Simply we will take the dot of electric field and area vector. Electric field and area vector. And if suppose कि field is not uniform nor the area vector is uniform throughout the area, then what to do? See, this is the basic formula, this is the definition of flux. So we have to search for a small area over the big area. We have to search a small area. हमें एक small area search करना होगा जिसमें कि इलेक्ट्रिक फील्ड कांस्टेंट हो। मींस we have to find the small area over which electric field could be constant. Then there is no problem, I can apply the dot of E and A over that area. So this will give the small flux d phi, and if I will sum all those flux due to small area, then it will give the total flux. That is, we have to integrate. So in the first case we will simply take the dot, and in another case E dot dA, its integral over the surface. So these things, most of these things we have discussed in the last video. So in this video basically I am going to do some numericals. We will do one question of each category, one question from this and one question from this to illustrate better. So first start a question from this concept. This is my coordinate axis, x, y and z axis, and this is the origin. Now suppose I'm taking a cubical surface, I'm taking a cubical surface along this. So suppose this is my upper surface, surface number 1. This is right side surface, surface number 2, and say this is my surface number 3. And this distance is 1 meter, and the side length is 2 meter. The side length of this cube. And here in this region an electric field 3x I cap plus 4j cap exists in this region. So the question is to find the electric flux through surface 1, 2 and 3. Find the electric flux through surface 1, 2 and 3. Fine. We have to find the flux through all these three surfaces. So its solution. First of all, we will start for the surface 1. For surface 1. See, the if I talk about a particular surface, then what happened? This field lie in xy plane. So for surface 1, we have to find E and A. First, we will find E and then find A. So for surface 1, we can note one thing: x is varying point to point. If I will move from this end to this end, x is varying. So the x component of field is variable and y component is fixed. So simply I am writing E is equals to 3x I cap plus 4j cap. And now what about the area vector? A is what? We have discussed in the last video that this is a closed surface, closed cube. So the surface vector has a direction of outward normal. So if I draw this outward normal, it must be in this direction. So this is the direction of j cap, and this is the direction of I cap, and this is the direction of k cap. So my area vector is in the direction of j cap, and the area is 2 by 2, so it is 4 meters square. So 4j cap. Side length is 2, so area of the one face is 2 into 2, 4 meters square. So it is 4j cap. Now we will take the dot. So flux will be what I am writing upside. So phi is equals to, say phi 1 is equals to E dot A, that is 3x I cap plus 4j cap dot 4j cap. So I cap dot j cap is 0. You know कि I and j is at 90 degree. So dot product will be 0 for this two, and it is 16 for this. So 16 Newton per Coulomb meter square is the flux for first surface. Now for second surface, second surface it is parallel to YZ plane. So its area vector will be in this direction, and x coordinate is fixed. For this plane, all the point lying on this plane has a fixed value of x, that is 1 plus 2, 3. So E is what? 3 into 3, 3x. So at the place of x we will put 3. 3 into 3 I cap plus 4 j cap, that is 9 I cap plus 4 j cap. And area vector is outward normal, so it is toward the I cap, and the area magnitude of the surface area is 4. So 4 I cap. Again, simply we will take that out of this 2. So phi 2 again we can find. Therefore, phi 2 is equals to 9 I cap plus 4 j cap dot 4 I cap. So again I cap 9 into 4 36 and j and I 0. So 36 Newton meter square per coulomb. So this is the flux through the second surface. Similarly for third surface, the area vector will be this side, this direction, outward. So outward of this cube, so it is in this direction. So and the x is equals to 1 for this surface. All the point on the surface number 3 having x coordinate 1. So we can write E is equals to 3 into 1 I cap plus 4j cap, that is 3 I cap plus 4j cap, and the area vector is pointing toward minus I. So area vector is equals to minus 4 I cap. Again we will take that out of this 2, and the phi 3 we will get in the similar manner. Phi 3 is equals to E dot A, that is 3I plus 4j dot minus 4I dot minus 4 I cap. So it is 3 and 4 12, minus 12, this will be 0 Newton meter square by coulomb. So here the flux is negative. So you can notice one thing, entering flux is negative and leaving flux will be positive. The surface through which the electric field is exiting, the flux will be positive, and the surface through which the electric field is entering, the flux will be negative. So field is entering at the surface number 3 and exiting from these two, 1 and 2. So for 1 and 2 it is positive, and for 3 it is negative. So now for the second case, if here the electric field was constant, not varying, and the area is also fixed throughout the surface, that there is unit direction. So this lies in case 1. Now in case 2, if suppose electric field is variable, so this is a good question, frequently asked in the exams also. Suppose there is a circular disc of radius capital R, and a point charge Q is placed at its axis at a distance of small r, and suppose electric field lines is emerging from this, and we have to find the flux of this electric field through this disc. So one thing is very clear कि at the different point the distance from this point is different, so electric field is also different. तो अलग अलग पॉइंट पे क्या है, इलेक्ट्रिक फील्ड के स्ट्रेंथ अलग अलग है, तो इलेक्ट्रिक फील्ड वेरिएबल हुआ। तो ऐसे केस में हम किसी एक वैल्यू को चूज नहीं कर सकते कि ई डॉट ए कर देंगे। तो ऐसे केस में हम क्या करेंगे, एक ऐसा एरिया चूज करेंगे जहां पे इलेक्ट्रिक फील्ड वेरी ना हो, और पहले हम उसके थ्रू फ्लक्स फाइंड करेंगे। तो सेम इलेक्ट्रिक फील्ड वाला एरिया ढूंढना है जहां इलेक्ट्रिक फील्ड सेम हो। तो एक पॉइंट चार्ज से इक्वल डिस्टेंस पे ही इलेक्ट्रिक फील्ड इक्वल होता है। तो हम यहां से सपोज किसी x डिस्टेंस पे एक रिंग कंसीडर करेंगे, सपोज कि ये डिस्टेंस x है और इसका थिकनेस है dx। तो इस रिंग के सारे पॉइंट का डिस्टेंस इस पॉइंट से इक्वल है, एंड दैट इज रूट अंडर आर स्क्वायर प्लस एक्स स्क्वायर। तो इन सारे जगह पे क्या होगा, इलेक्ट्रिक फील्ड सेम होगा, तो हम फ्लक्स फाइंड कर सकते हैं। ये हमारा एरिया वेक्टर हो गया dA, और ये हमारा इलेक्ट्रिक फील्ड हो गया E, ये हमारा एंगल हो गया थीटा। तो सबसे पहले हम लिख लेंगे कि E की वैल्यू क्या होगी। रिंग के पास इलेक्ट्रिक फील्ड कितना हो जाएगा, Q बाई 4 पाई एप्सिलॉन नॉट आर स्क्वायर, दिस डिस्टेंस इट्स स्क्वायर, दैट इज आर स्क्वायर प्लस एक्स स्क्वायर। ये हमारा इलेक्ट्रिक फील्ड है। एरिया डीए कितना हो जाएगा, इस रिंग का एरिया, हमारा एरिया हो जाएगा 2 पाई एक्स इंटू डी एक्स। सपोज इट्स थिकनेस इज dx, इसका थिकनेस हमारा dx है, तो ये हो जाएगा 2 पाई एक्स dx, पेरीमीटर इनटू thickness। 2 pi x is the perimeter, dx thickness, so perimeter multiplied by thickness is the area. Okay, so dA I got, fine. Now the flux is E dot dA, so let the flux associated through this small area is d phi, then d phi, the small amount of flux associated with this ring is E dot dA, that is Q by 4 pi epsilon naught R square plus X square into 2 pi X dx and cos theta. E dot d means E into dA into cos theta. So cos theta will be what? This angle is also theta. If this is theta, this is also theta. So it is B by H. Base is the small r and hypotenuse is root under r square plus x square. So it is r upon root under of r square plus x square. So this is the d phi. I got the flux through this small area, a concentric ring of radius x and thickness dx. Now this entire disk is made up of so many small rings. So if I integrate from x0 to capital R, I will get the total flux. So let's do it. D phi, again writing D phi Q into R, Q into R into x dx, x dx, q into r into x dx divided by 2 epsilon naught r square plus x square to the power 3 by 2. So this is the final defy. So phi is equals to what? Integral of d phi, that is integral of q r x dx upon twice epsilon naught r square plus x square to the power 3 by 2 from x is equals to 0 to x is equals to capital R. So this is the thing. So to solve this integration, I will use the method of substitution. I will substitute r square plus x square equals to t square. Let r square plus x square is equals to t square. Differentiating both sides, what we will get? R is the constant, so it is 0. 2x dx is equals to 2t dt. That is x dx is equals to t dt. I got x dx equals to t dt. I will use this result here. Therefore, phi can be written as integral of, okay, the constant thing we can take outside, like q, r and 2 epsilon naught. These are the constant thing, we can take it outside. q r by 2 epsilon naught, integral of x dx, in place of x dx I am writing t dt. And r square plus x square equals to t square. So it is t square to the power 3 by 2. That is phi is equals to q r by 2 epsilon naught. This 2 will cancel out, so it is tq and dt by t square 0 to this implies that phi is equals to q r by 2 epsilon naught into minus 1 by t 0 to r. 1 by t square, its integration is minus 1 by t. Again we will come back to our integration, substitution. R square plus x square equal to t square. So t is again root under r square plus x square. Finally, phi is equals to q r by 2 epsilon naught 1 by root under r square plus x square 0 to r. So phi is equals to q r by 2 epsilon naught minus 1 by root under r square plus r square, and again minus minus plus 1 by r. So finally phi is equals to multiplying, so it is q by 2 epsilon naught, taking outside, r taking inside, so it is 1 minus r upon root under r square plus r square. So this is the flux. This is the flux through that disk of radius r, and the charge is placed at its axis at a distance small r. So the situation is something like this is the disk, here is the point charge, and if this angle is theta, suppose, or alpha, whatever, suppose this is angle alpha, then flux can be written as q by 2 epsilon naught into 1 minus, this is root under r square plus r square, so 1 minus cos alpha. So this is the result for the flux through a disk. आज की इस वीडियो में इतना ही। अगले वीडियो में हम डिस्कस करेंगे गॉस लॉ और देखेंगे कि अगर सरफेस क्लोज हो तो हम कैसे उसके थ्रू फ्लक्स फाइंड कर सकते हैं। थैंक यू वेरी मच।